Something on Titan is eating hydrogen, and nobody on Earth can tell you what. Every year, molecules of hydrogen gas drift down through Titan's thick orange atmosphere, hit the surface, and vanish. Not react, not scatter. Vanish, like something down there is inhaling them. We found this out in 2010, buried in a spreadsheet of Cassini spacecraft data. A researcher named Darrell Strobel ran the numbers, ran them again, and then published a paper that quietly detonated inside the astrobiology world. Because there are a few possible explanations for what he found, but only two that fit the data cleanly. Either there's some exotic, never-before-seen chemistry happening on Titan's surface, or something down there is alive, and it's breathing. That paper is still sitting in the record, unresolved 16 years later. I'm going to show you exactly what could be causing it. And by the end of this, you'll understand why Titan has become one of the most compelling places in the solar system to look for life. But to understand why the hydrogen matters, you need to see Titan for what it actually is. And trust me, you've never seen a place like this. Picture yourself standing on a beach at dusk. Waves lap at your boots. A soft orange haze blankets the sky, so thick you can't see the sun, just a dim glow like a lamp behind frosted glass. You scoop up a handful of sand, it crunches. Except it isn't sand, it's frozen hydrocarbons. Basically the stuff we burn in our cars, packed into grains and blown into dunes hundreds of miles long. The waves in front of you. Liquid methane. The air. Nitrogen so dense that if you strapped cardboard wings to your arms and jumped off a cliff, you could actually fly. Not glide, fly. The gravity is weak, the atmosphere is thick, and physics just hands you a superpower. I remember reading that fact in a textbook back in high school. Closed the book, stared at the ceiling for a good 10 minutes, thought, no way, checked 3 sources. It was real. That's the moment I fell down the rabbit hole I'm still in. Titan is bigger than the planet Mercury. If it were orbiting the sun instead of Saturn, we'd call it a planet without blinking. It has weather, seasons, rain, rivers that carve into bedrock made of ice. Ice so cold it's harder than granite. It has coastlines, sunsets, clouds drifting lazily across the sky. If you swap the colors in a Titan photo, turn the orange sky blue and the black lakes clear, you'd swear you were looking at rural Iceland. But everything on Titan is a chemical lie. Nothing is what it looks like. And all of this would already make Titan extraordinary. But none of it explains the hydrogen. Titan's rain falls in slow motion. Big, fat methane droplets, roughly the size of marbles, drift down through the thick air at about the speed of a snowflake here on Earth. A single raindrop takes almost a full minute to fall from cloud to ground. Getting caught in a Titan storm wouldn't feel like a downpour. It'd feel like walking through the world's slowest, coldest car wash. Up in Titan's upper atmosphere, sunlight breaks apart nitrogen and methane and reassembles the pieces into complex reddish-brown organic molecules called tholins. Tholins drift down like snow, constantly, for billions of years. Titan is literally being coated day after day in the raw prebiotic chemistry that some scientists think helped start life on Earth. That's not a theory I'm dressing up for the video. That's the actual composition of the ground you'd be walking on. And here's the part that gets me. We've actually been there. In 2005, a small probe called Huygens hitched a ride on Cassini and parachuted through Titan's atmosphere. It survived the landing. It sent back photos of a rocky, muddy landscape that looked eerily like a dry riverbed on Earth. But it also did something almost nobody talks about. It recorded sound. Actual audio from the surface of a moon a billion miles away. Wind moving through the alien air. The soft crunch as the probe settled into the ground. If you go looking, you can find the recordings. And hearing wind on Titan is one of those moments that recalibrates what far away even means. Now stack this up. Organic snow falling for billions of years. Liquid methane lakes the size of the Great Lakes. A thick, protective atmosphere. Wind you can hear. And underneath all of it, an ocean. Under 60 miles of frozen crust, Titan is holding a global ocean of liquid water, kept warm by internal heat, laced with ammonia like antifreeze, potentially larger than every ocean on Earth combined. It's been down there undisturbed for billions of years. Every ingredient the textbook tells you life needs: liquid water, organic molecules, energy, time, Titan has in absurd quantities. But Titan doesn't just check the life as we know it box. It might check a box we didn't know existed, because on the surface, in those methane lakes, some astrobiologists have proposed something unusual. They've worked through the chemistry in detail. Under Titan conditions, you could theoretically build a cell, not like ours, but functional. A membrane made from nitrogen compounds. A metabolism that consumes hydrogen and acetylene instead of oxygen and sugar. And the byproduct of that kind of metabolism would be simple: hydrogen disappearing at the surface. The exact pattern Strobel's paper measured. Now, to be clear, this is not proof of life. The hydrogen loss could come from unknown surface chemistry. It could be catalyzed reactions we haven't replicated yet. It could even be a subtle modeling or measurement issue. But 16 years later, we still don't have a definitive answer. And in science, things that stay unexplained that long tend to matter, which is why we're going back. NASA is launching a nuclear-powered drone called Dragonfly in 2028, about the size of a small car, 8 rotors, and when it arrives at Titan in 2034, it's going to fly, properly fly, through a dense alien atmosphere. It will hop from site to site, land, sample, and take off again for years. And it's heading to Selk Crater, because that crater is a natural chemistry lab. A past impact would have melted water ice, mixed it with organics, and created a temporary environment where complex chemistry could run before freezing in place. If Titan has chemical fingerprints of life, or pre-life chemistry, that's one of the best places to find them. And then there are the lakes. In radar images, scientists have seen features they call magic islands, bright patches that appear, disappear, and shift over time. They might be waves, they might be bubbles, they might be floating material forming and breaking apart, or they might be something we don't yet understand about how Titan's surface chemistry behaves. That's the important part, because Titan keeps doing this. It keeps giving us phenomena we can describe, but not fully explain. The hydrogen flux is one of them. The lakes are another. Different systems, same pattern. The chemistry is active, dynamic, and not fully accounted for. If we find life on Titan, even microbial, even strange, the implications are immediate. The probability of life in the universe wouldn't just increase, it would collapse upward, because it would mean life doesn't require Earth-like conditions. It doesn't require liquid water at the surface. It doesn't require oxygen. It just requires chemistry, stability, and time. And the universe has those everywhere. Earth wouldn't be special. It would be one example, one recipe. And somewhere on Titan, right now, hydrogen is disappearing into the surface. We don't know why. But whatever the answer is, it's telling us we don't understand something fundamental yet.